July 1st, 1944. Hollandia Air Base, New Guinea. For P-38 Lightnings land following 6.5 hours above hostile territory. 3 aviators exit their cockpits with fuel indicators showing nearly dry, perhaps 50 gallons remaining in each plane. The fourth machine, piloted by a 42-year-old civilian, still registers 210 gallons left. Identical assignment, identical conditions, identical aircraft. Yet this particular aviator consumed 200 gallons less than the finest fighter pilots in the Pacific. The crew chief examines his measuring rod, then verifies it once more. For months, American aviators had operated these twin-engine fighters precisely as the handbook required. 20 to 100 RPM, auto-rich fuel mixture configurations, adhering to every protocol hammered into them throughout flight training. They had learned that straying from these specifications would ruin their power plants. That operating oversquare, elevated manifold pressure combined with reduced RPM meant certain aviation disaster. But standing on that New Guinea airstrip, observing fuel measurements that contradicted everything the Army Air Forces accepted about power plant operation, one question lingered in the thick Pacific atmosphere. What if their entire training had been fundamentally flawed? The checkers match had continued for 20 minutes when someone knocked at the screen entrance. Colonel Charles McDonald hardly looked up from the red and black game board, his thoughts still working through potential moves while the afternoon humidity weighed down on their temporary headquarters at Hollandia Air Base. Lieutenant Colonel Merrill Smith occupied the seat across from him, similarly focused on their makeshift pastime, among the limited diversions available in this remote corner of Netherlands, New Guinea. "Excuse me, gentlemen." The statement carried understated confidence that finally drew McDonald's attention toward the entrance. A middle-aged figure in navy khakis stood there, his uniform immaculate despite the moisture. "I am Charles Lindbergh." McDonald's hand stopped midway to a checker piece. The name hung suspended like vapor from a downed aircraft. Smith's eyes widened marginally, but McDonald found himself studying this ordinary-appearing civilian, attempting to match the legend with the person before them. That Charles Lindbergh, the one who completed the solo Atlantic crossing 17 years ago. "General Hutchison sent me," Lindbergh proceeded, entering their confined space. "He suggested I might discuss P-38 combat missions with you." McDonald rose gradually, the checkers game abandoned. At 29, he led the 475th Fighter Group, but he had matured reading about Lindbergh's ocean crossing. Every aviator in America knew the story. The spirit of St. Louis represented more than aviation history. It marked the moment flying evolved from carnival attractions to legitimate transport. And now, that same aviator stood in their shelter, inquiring about their operational reality of conducting missions across the immense Pacific. "Of course, Mr. Lindbergh, please have a seat." McDonald indicated a collapsible chair, then summoned Colonel Warren Lewis. If they intended to examine P-38 missions, Lewis should participate. The squadron commander of the 433rd Fighter Squadron understood better than anyone the crushing arithmetic of their present circumstances. Lewis appeared within minutes, his flight gear still moist with perspiration from the morning's planning session. He glanced at their visitor, and his military bearing faltered slightly. "Mr. Lindbergh, what brings you to our modest corner of paradise?" The irony escaped no one. Paradise, if paradise consisted of metal structures baking beneath tropical sun, mud that never fully dried, and the perpetual hum of insects that seemed resistant to every repellent the supply officer could obtain. But Lewis's inquiry was sincere. What could aviation's most celebrated pilot want with their fighter operations? "I'm here to observe," Lindbergh responded simply, "and perhaps share certain findings about extended range flying." Lewis settled into another collapsible chair, and McDonald watched him mentally transition into briefing posture. "Well, Mr. Lindbergh, our circumstances are quite clear. We're conducting missions that test every boundary these machines possess." The colonel extracted a worn chart, spreading it across McDonald's workspace and displacing the checkerboard. His finger tracked routes across hundreds of miles of blue Pacific expanse, marked with tiny islands that appeared inconsequential on paper but represented crucial navigation references for aviators flying alone over boundless ocean. 6 to 7 hours, Lewis continued, his tone adopting the measured quality of someone who had calculated these figures too frequently. That's what we're demanding of these young men now. Assignments that were unthinkable a year ago are becoming standard, and the fuel margins, he shook his head. MacDonald observed Lindbergh examine the chart with the concentration of an engineer studying technical drawings. Those light blue eyes moved methodically from island to island, computing distances with the exactness of someone who had dedicated decades to considering range and endurance. It was the expression of an aviator who comprehended that fuel wasn't merely a gauge reading. It was time, distance, and ultimately survival. The P-38L has a documented combat range of 570 miles, Lewis clarified. In reality, we're exceeding that threshold every single assignment. Standard protocol requires 2200 to 2400 RPM, auto-rich mixture configurations. Fuel usage runs above 100 gallons hourly total. Lindbergh nodded deliberately, but MacDonald detected something in his manner. Not puzzlement, but acknowledgement. Like a technician hearing symptoms he had diagnosed previously. These young men returned completely drained, Lewis went on. 7 hours in that cockpit is torment, sitting on a parachute, emergency flotation device, and or. The physical burden is one consideration, but the mental strain. He gestured toward the chart again. Every mission planning becomes a fuel computation. How much safety margin? How long can we maintain position over the objective? What's our absolute point of no return? MacDonald had witnessed that stress directly. Young aviators, some barely 21, hunched over flight planning desks with slide rules and pencils, computing margins that determined whether they would see another dawn. Too many capable men had already been lost to depleted tanks rather than hostile fire. The mathematics were merciless. Exhaust your fuel over the Pacific, and recovery was improbable at best. And it's deteriorating, Lewis added softly. The objectives keep growing more distant. Rabaul Wewak. Now we're discussing assignments deep into the Philippines. The conflict is advancing west, but our fuel capacity isn't expanding with it. Lindbergh listened without interjecting, occasionally posing questions about mixture configurations, propeller pitch, or cruise elevations. His inquiries were precise, technical, and displayed a depth of understanding about aircraft mechanics that surprised MacDonald. This wasn't simply a famous name asking courteous questions. This was an aviator who grasped power plant operation at a level most combat flyers never achieved. Have you tested alternative cruise configurations? Lindbergh finally inquired. Lewis and MacDonald exchanged looks. The technical directives are quite explicit, Lewis replied cautiously. We follow established protocols for power plant operation. High RPM, rich mixtures. That's what keeps these Allisons functioning. Something in Lindbergh's manner shifted almost imperceptibly. Not contradiction exactly, but the expression of someone who had heard conventional doctrine that didn't align with his experience. Mr. Lindbergh, MacDonald said slowly, you mentioned findings about extended range flying. What kind of findings? For the first time since entering their quarters, Lindbergh smiled faintly. Would you be interested in a practical demonstration? I qualified in the P-38 several days ago, flying Dick Bond's former aircraft to the base. I'd like to accompany one of your combat assignments. The request hung in the humid atmosphere between them. MacDonald felt the burden of leadership settling on his shoulders. Taking a civilian, even Charles Lindbergh, on combat missions carried hazards that extended far beyond normal operational parameters. But something in the man's calm assurance suggested this wasn't casual interest. What did you have in mind? MacDonald asked. The recreation facility at Hollandia had witnessed better times, though MacDonald couldn't recall when. Dirt floors compressed solid by months of foot traffic, palm frond roof that leaked during afternoon storms, and a single ping-pong surface that served as the squadron's principal entertainment when they weren't conducting missions or servicing aircraft. Exposed light fixtures hung from the beams, producing stark shadows that made every face appear older and more exhausted than it should. McDonald stood near the improvised podium, really just a wooden container turned upright, and surveyed the gathered aviators of the 475th Fighter Group. 43 men, most under 25, all displaying the 1,000-yard stare that came from too many hours over enemy territory with fuel gauges perpetually in mind. Some occupied folding chairs salvaged for various supply depots. Others sat cross-legged on the ground, and several leaned against the walls with arms folded. "Gentlemen," MacDonald began, his voice cutting through the quiet murmur of conversation. "Mr. Lindbergh has information he wants to present about extending our range capabilities." Lindbergh stepped forward with the measured confidence of someone familiar with addressing doubtful audiences. He wore the same Navy khakis from their conference 2 days prior, though now MacDonald noticed the subtle details that marked him as different from standard military issue. The civilian timepiece, the lack of regulation insignia, the way he moved with the unconscious ease of someone who had spent decades around aircraft. "Reduce your standard 20 to 100 RPM to 1600, Lindbergh stated without preamble. No introduction, no background, just a technical specification that would either preserve lives or destroy power plants. Set fuel mixtures to auto-lean instead of auto-rich. Increase manifold pressures moderately to compensate." The silence that followed was the type MacDonald had heard before. Not confusion, but the mental grinding of aviators attempting to reconcile what they had just heard with everything they had been taught. Lieutenant Bobby Johnson, one of their most reliable formation leaders, raised his hand tentatively. "Sir, are you suggesting we can reduce RPM down to 1600 and use 30 inches of mercury manifold pressure?" "That's accurate," Lindbergh confirmed. "The fuel savings range between 50 and 100 gallons per assignment, depending on conditions and flight duration." The silence intensified. MacDonald watched his pilots' faces, reading the mixture of hope and dread playing across their features. Hope because extended range meant improved survival odds, greater tactical flexibility, and the capability to reach objectives that had been beyond their grasp. Dread because every flight instructor, every technical handbook, every power plant school had taught them the same fundamental principle: never operate oversquare. Captain Jim Watkins voiced what everyone was thinking. "Mr. Lindbergh, that's going to destroy our power plants. We've always been taught that low RPM with high manifold pressure causes detonation." "You've been taught incorrectly," Lindbergh interrupted, his voice carrying the calm authority of absolute certainty. "The technique functions because you're maintaining high manifold pressure while reducing RPM, not operating both high simultaneously. Combined with auto-lean mixture configurations instead of auto-rich. This reduces fuel consumption to approximately 70 gallons hourly total." Lieutenant Thomas Hayes, barely 22, and still carrying the enthusiastic intensity of someone who had completed flight school 6 months earlier, performed the calculations aloud. 70 gallons hourly versus our current 100 plus. That's almost a 30% reduction. "More than that," Lindbergh replied. "Flying at 185 miles per hour indicated airspeed. This technique provides roughly 2.6 miles per gallon. Your combat range extends from 570 miles to 700, possibly 750 miles, depending on conditions." The figures hung in the humid atmosphere like artillery rounds waiting to explode. MacDonald could see his aviators performing calculations, attempting to grasp what those numbers meant in practical terms. 750 miles combat range translated to assignments they had previously considered impossible. Deep strikes in a Japanese-controlled territory that had been beyond their fuel envelope. But the resistance ran deeper than simple mathematics. These men had survived combat by adhering to procedures that kept their power plants functioning and their aircraft flying. The Allison V. 1710 power plants in their P-38s were temperamental enough under normal conditions. Tampering with established cruise configurations felt like gambling with their lives. "Sir," said Major Pete Peterson, a veteran of assignments over Rabaul who had earned his skepticism through hard experience, Every technical directive we've seen warns against oversquare operation, the risk of power plant knock, piston damage. The procedure appears controversial because you've been trained to believe it would damage power plants, Lindbergh replied patiently. But consider the source of that training. How many of your instructors had experience with sustained extended-range cruise flight? How many had operated these specific power plants under prolonged endurance conditions? The question cut to the heart of their dilemma. Military flight training emphasized combat maneuvering, formation flying, and gunnery, not the kind of efficient extended-range cruise techniques that Lindbergh had perfected during his decades of civilian aviation. The technical directives were written by engineers who prioritized power plant longevity over operational range, assuming that fuel capacity rather than consumption would determine mission boundaries. Lieutenant Colonel Smith, who had been silent during Lindbergh's explanation, finally spoke. "Mr. Lindbergh, you're asking us to conduct 9-hour assignments. 7 hours in a Lightning cockpit is already torture. Sitting on emergency equipment, dealing with oxygen system quirks, fighting fatigue that affects judgment." He gestured toward the assembled aviators. 9 hours seems beyond human endurance. McDonald nodded grimly. The physical challenges were genuine and couldn't be dismissed. 38 cockpits were cramped under the best circumstances, and extended assignments meant sitting on parachutes, emergency flotation devices, and survival gear for hours at a time. Oxygen masks became increasingly uncomfortable. Radio headsets caused pressure points, and the mental strain of navigation over featureless ocean wore down even experienced aviators. The endurance challenge is legitimate, Lindbergh acknowledged. But consider the alternative. How many aviators have you lost to fuel starvation? How many assignments have been aborted because fuel margins didn't allow sufficient time over objective? The question struck home because every aviator in the room knew the answers. Too many capable men had disappeared over the Pacific, their aircraft simply vanishing when fuel ran out hundreds of miles from land. Others had been forced to turn back shore of their objectives, allowing hostile installations to remain operational for lack of sufficient fuel to complete attacks. The choice isn't between comfort and discomfort, Lindbergh continued quietly. It's between proven techniques that extend your operational capability and conventional methods that may be limiting your effectiveness unnecessarily. McDonald studied the faces around him, reading the mixture of curiosity and concern in their expressions. These were combat veterans who had learned to trust their equipment and their training, but they were also pragmatists who understood that survival often depended on adapting to new information. "Mr. Lindbergh," McDonald said finally, "would you be willing to demonstrate this technique on an actual combat assignment?" The morning of July 3rd dawned clear over Hollandia, with visibility extending to the horizon for the first time in a week. McDonald stood beside his P-38 Lightning at 0530, watching ground crews complete their pre-flight inspections while the tropical atmosphere still carried the relative coolness of night. Today's assignment would test everything Lindbergh had claimed about fuel operation, a 1,280-mile round trip that would push even conventional fuel planning to its absolute boundaries. Lindbergh emerged from the operations shelter carrying his flight gear with the deliberate movements of someone who had performed this ritual thousands of times. His borrowed flight suit fit reasonably well, though McDonald noticed he wore civilian flying boots instead of standard military issue. More telling was the ease with which he handled his equipment: parachute harness, Mae West life jacket, oxygen mask, and survival kit arranged with the efficiency of long practice. "Weather looks favorable for the demonstration," Lindbergh observed, glancing toward the eastern horizon where the sun was beginning to burn off the overnight haze. "Visibility should remain clear for navigation, and winds are minimal." McDonald nodded, though his attention was focused on the fuel calculations he had run 3 times during the night. Standard cruise configurations would require every drop of internal fuel capacity with virtually no reserve for combat maneuvering or unexpected headwinds. If Lindbergh's technique failed to deliver the promised savings, they would be calculating glide ratios over open ocean. "Tommy's flying your wing today," McDonald said, indicating where Major Thomas McGuire was completing his own pre-flight inspection 2 aircraft down the flight line. He'll be monitoring your fuel consumption closely. McGuire looked up at the mention of his name, offering a brief wave. America's second high-scoring ace had volunteered for this assignment specifically to observe Lindbergh's methods under combat conditions. If the fuel operation technique worked for someone with McGuire's aggressive flying style, it would work for anyone in the squadron. The briefing had been straightforward. Patrol sectors northeast of their current position with possible ground attack opportunities against Japanese supply installations on several small islands. Nothing extraordinary by their recent standards, but the distance involved would test both fuel efficiency and human endurance. Lindbergh climbed into his cockpit with practiced efficiency, his movements economical and precise. McDonald watched him run through his checklist, noting that the civilian aviator took extra time with fuel system configurations. Unlike standard military procedure, Lindbergh adjusted his mixture controls to auto-lean configurations before power plant start, and his propeller controls were set for lower RPM than any P-38 aviator had been trained to use. Power plant start proceeded normally, both Allison V-1710s coming to life with their characteristic whine as turbo superchargers spooled up to operating speed. But once taxi clearance came through, McDonald noticed the difference immediately. Lindbergh's power plants ran noticeably quieter than standard configurations, their exhaust note deeper and less aggressive. Hollandia Tower, Lightning Flight requesting takeoff clearance, McDonald transmitted. Lightning Flight cleared for takeoff, runway 27. Wind calm, visibility unlimited. The 4 P-38s lifted off in formation, climbing steadily through 3,000 feet as they headed northeast toward their patrol area. McDonald kept his throttles and mixture controls at regulation configurations while maintaining visual contact with Lindbergh's aircraft flying on his right wing. Even during climb, he could see that Lindbergh's power plants appeared to be developing identical power despite their different configurations. At cruise altitude, the demonstration began in earnest. Lindbergh's voice came through the radio with technical precision. Reducing RPM to 1600, manifold pressure 30 inches, mixture auto-lean, airspeed 185 indicated. McDonald cross-checked his own instruments. His aircraft was consuming fuel at the expected rate, approximately 52 gallons per hour per power plant, or 104 total. But visual observation suggested Lindbergh's aircraft was maintaining identical airspeed and altitude despite its radically different power plant configurations. The first hour passed uneventfully, with navigation proceeding exactly as planned. McDonald found himself checking fuel flow instruments more frequently than usual, comparing his consumption rates against mission planning calculations. Everything matched expected performance, which made Lindbergh's claim seem increasingly significant. If the civilian aviator was actually achieving 30% fuel savings while maintaining cruise performance, the implications for Pacific operations were staggering. McGuire's voice broke radio silence at the 1 hour 30-minute mark. Lead, I'm showing fuel flow approximately 20% below normal for this phase of flight. The transmission confirmed what McDonald had begun to suspect. Even McGuire, flying standard cruise configurations but observing Lindbergh's technique closely, was unconsciously adopting more efficient power operation. The psychological effect of watching fuel conservation in action was influencing flying habits across the formation. 2 hours into the assignment, they encountered their first tactical situation. Intelligence reports had indicated possible Japanese barge traffic near Samate Island, and visual reconnaissance confirmed several targets anchored in a protected cove. Standard attack procedure called for high-speed passes with full power configurations, exactly the kind of fuel-intensive maneuvering that made extended-range assignments problematic. Lightning Flight, this is lead. Target area ahead. Prepare for ground attack. McDonald pushed his throttles forward, feeling both power plants respond with increased power as fuel flow jumped to maximum combat configurations. The attack run proceeded normally. Diving approaches, multiple strafing passes, and defensive maneuvering to avoid anti-aircraft fire. But he noticed that Lindbergh maintained formation throughout the engagement, his aircraft responding normally to combat power demands despite its unconventional cruise configuration. The engagement lasted 12 minutes with all four aircraft expending significant ammunition against barges and shore installations. During the climb back to cruise altitude, McDonald reset his power plants to standard extended range configurations while monitoring fuel remaining. Combat power had consumed fuel at expected rates, leaving him with approximately 60% capacity for the return flight. Lead, fuel check, McDonald transmitted. 2 showing 60% remaining, came McGuire's reply. 3, 58%. 4, 72% remaining, Lindbergh reported quietly. McDonald double-checked his radio, certain he had misheard the transmission. 72%? After 2 hours of cruise flight and 12 minutes of combat maneuvering, Lindbergh still had nearly 3/4 of his fuel load remaining. The numbers were impossible according to everything McDonald understood about P-38 fuel consumption. 4. Say again, fuel remaining. 72% confirmed, Lindbergh replied. Fuel flow during cruise has averaged approximately 70 gallons per hour total. The mathematics were undeniable. While McDonald's aircraft had consumed roughly 200 gallons during the first phase of their assignment, Lindbergh had used only 140 gallons for identical distance and flight time. The 30% reduction in consumption was exactly what he had promised during the briefing, but seeing it demonstrated under combat conditions transformed theoretical possibilities into operational reality. The return flight provided additional confirmation. Despite maintaining formation airspeed and altitude, Lindbergh's fuel consumption remained consistently lower than standard cruise configurations. By the time Hollandia came into sight, McDonald was calculating fuel margins that seemed almost luxurious compared to their normal type planning. Landing revealed the full extent of the demonstration success. Ground crews immediately began fuel measurements using calibrated dipsticks to determine exact consumption for each aircraft. McDonald had returned with 18% fuel remaining, adequate for assignment completion, but offering little reserve for unexpected circumstances. Lindbergh climbed out of his cockpit with 34% fuel still in his tanks. The skepticism cracked first among the ground crews. Technical Sergeant Mike Kowalski had been working on P-38 power plants since before Pearl Harbor, and he understood fuel consumption the way a banker understood compound interest, through daily, meticulous observation of numbers that never lied. When Lindbergh's Lightning consistently returned from assignments with fuel readings that defied every handbook Kowalski had studied, the veteran mechanic began asking questions that cut through military hierarchy. "Colonel McDonald, sir," Kowalski said after the 5th consecutive assignment where Lindbergh's fuel consumption ran 30% below standard rates. "Either this civilian's got magic power plants or everything we've been taught about cruise configurations is wrong." McDonald found himself nodding more frequently during these conversations. The evidence was mounting with mathematical precision that couldn't be dismissed or explained away. Assignment after assignment, Lindbergh returned with fuel quantities that should have been impossible given the distances flown and time airborne. More significantly, his power plants showed no signs of the damage that military doctrine insisted would result from oversquare operation. The aviator's resistance proved more stubborn than mechanical evidence. Lieutenant Hayes, who had volunteered to try Lindbergh's technique on a training flight, returned from his first attempt visibly shaken by the psychological pressure of operating power plants in configurations that contradicted everything he had been taught. "It felt wrong the entire time, sir," he reported to McDonald, "like waiting for something to explode." But Hayes also reported fuel consumption that matched Lindbergh's claims almost exactly, 73 gallons per hour total compared to his usual 100-plus gallon burn rate. The lieutenant's fuel gauges didn't care about his psychological comfort. They simply recorded the mathematical reality of improved efficiency. Major Peterson represented the old guard's final stand against the new technique. A veteran of assignments over heavily defended Japanese positions, Peterson had survived by following procedures that kept his aircraft flying when other aviators pushed their luck too far. Mr. Lindbergh, he said during one particularly heated discussion in the operations shelter, "You're asking us to bet our lives on techniques that go against everything we know about power plant operation." Lindbergh's response carried the patient tone of someone accustomed to technical skepticism. "Major, what you know about power plant operation comes from training designed for different operational requirements, short duration flights, maximum power configurations, and conservative safety margins appropriate for training environments." He gestured toward the mission planning board covered with routes that stretched hundreds of miles across empty ocean. These assignments demand efficiency techniques that weren't part of standard military curriculum. The breakthrough came during an assignment to Wewak on July 28th. McDonald had planned the strike as a standard formation attack against Japanese supply installations, but intelligence reports suggested heavy fighter opposition, the kind of extended air-to-air combat that would test every aspect of aircraft performance under the most demanding conditions possible. Lindbergh flew on McGuire's wing that day, positioning himself where the squadron's most experienced combat aviator could observe his techniques during actual aerial combat. The assignment profile called for a 400-mile transit to the target area, followed by potential air-to-air engagement, ground attack, and return flight. Exactly the kind of complex operation where fuel operation could mean the difference between assignment success and disaster. They encountered Japanese aircraft exactly as intelligence had predicted, a formation of Mitsubishi Ki-51 dive bombers escorted by Zero fighters approaching Wewak from the northwest. The engagement began with standard tactics, altitude advantage, coordinated attacks, and aggressive maneuvering to gain firing positions. But as the dogfight extended beyond normal duration, fuel consumption became a critical factor for every aviator involved. McDonald watched the aerial combat unfold with the detached precision of a commander who had seen too many similar engagements. P-38's maneuvering against Japanese fighters in three-dimensional chess matches where split-second decisions determined survival. Ammunition expenditure, fuel burn rates, and tactical positioning all factored into calculations that aviators made instinctively while pulling multiple G-forces in combat turns. The Japanese formation leader, later identified as Captain Saburo Shimada, demonstrated the kind of aggressive flying that had made Zero aviators legendary during the early war years. Shimada's aircraft cut through defensive maneuvers with precision that suggested hundreds of combat hours, forcing American aviators to respond with maximum power configurations that consumed fuel at rates far above cruise consumption. McGuire's voice crackled through the radio during a brief lull in the engagement. Multiple bandits, ammunition running low, fuel becoming a factor. It was the kind of situation that separated experienced combat aviators from those who hadn't yet learned to manage multiple crisis factors simultaneously: ammunition, fuel, enemy aircraft capabilities, distance to base, and weather conditions all demanded immediate evaluation while maintaining situational awareness in three-dimensional combat. Lindbergh's aircraft maneuvered through the engagement with the same precise control he demonstrated during cruise flight. No wasted motion, no unnecessary power configurations, and consistent tactical positioning that suggested complete comfort with P-38 handling characteristics. When Shimada's damaged aircraft turned directly toward Lindbergh in what appeared to be a ramming attack, the civilian aviator's response was immediate and decisive. The brief engagement ended with Shimada's aircraft spiraling toward the ocean, trailing smoke and debris. Lindbergh had scored his first and only aerial victory of the war, but the significance extended beyond individual combat success. He had proven that fuel-efficient cruise techniques didn't compromise combat effectiveness when applied by aviators who understood both power plant operation and tactical flying. The return flight provided final confirmation of the technique's practical value. McDonald's formation had been airborne for over 8 hours, including extended combat maneuvering at maximum power configurations. Standard fuel planning would have left most aviators calculating emergency landing options or considering water landings if headwinds increased. Instead, they landed at Hollandia with fuel reserves that seemed almost luxurious. McDonald touched down with enough fuel remaining for another hour of flight. McGuire, who had been experimenting with modified cruise configurations throughout the assignment, reported similar margins. But Lindbergh's fuel gauges showed quantities that still seemed impossible, enough remaining fuel for nearly 2 additional hours of flight time. The ground crew's post-flight inspections revealed no power plant damage, no unusual wear patterns, and no mechanical problems that would suggest harmful effect from oversquare operation. Kowalski's detailed examination of Lindbergh's power plants actually showed slightly less wear than comparable aircraft operated under standard configurations, suggesting that efficient cruise techniques might actually extend power plant life rather than shorten it. Word of the combat's success spread through the 475th Fighter Group with the speed of all significant military news. Lindbergh had demonstrated fuel efficiency under the most demanding operational conditions, proven combat effectiveness against experienced enemy aviators, and returned with power plant condition that contradicted every warning about oversquare damage. Major Peterson approached MacDonald that evening with the grudging respect of someone whose professional skepticism had been overcome by undeniable evidence. "Colonel, I'd like to request permission to try Mr. Lindbergh's techniques on tomorrow's patrol assignment." The dam had finally broken. Within a week, every aviator in the squadron was experimenting with reduced RPM configurations and auto-lean mixtures. The results matched Lindbergh's predictions with mathematical consistency. 30% fuel savings, extended range capabilities, and no mechanical problems that hadn't been predicted by obsolete training doctrine. MacDonald realized they had witnessed more than a technical demonstration. They had seen institutional knowledge challenged and overturned by evidence that couldn't be dismissed or ignored. By August 1944, the transformation was complete. What had begun as one civilian's controversial suggestion had become standard operating procedure across every P-38 unit in the Pacific Theater. Flight handbooks were hastily revised, technical directives rewritten, and instructor aviators found themselves teaching techniques that directly contradicted everything they had learned during their own training. The institutional revolution had occurred with startling speed, driven by results that commanders couldn't ignore. MacDonald stood in the operations shelter, studying mission planning boards that would have been impossible just months earlier. Routes stretched deep into Japanese-held territory, 950-mile round trips to Balikpapan, extended patrols over the Celebes Sea, escort assignments that pushed P-38 capabilities to boundaries that previous doctrine had considered fantasy. The numbers told the story with mathematical precision. Combat range increased from 570 miles to 750 miles, fuel consumption reduced by 30%, and assignment capability expanded by 40% in flight time. Colonel Lewis approached with the latest operational reports, his expression carrying the satisfied look of an officer whose tactical problems have been solved by unexpected innovation. The 432nd Squadron completed an 8-hour escort assignment to Borneo yesterday, he reported. Full formation, no fuel emergencies, adequate reserves for combat maneuvering over objective. The significance wasn't lost on MacDonald. 8-hour assignments had been theoretical discussions just 4 months earlier. Now, they represented routine operations that aviators planned with confidence rather than desperate hope. The psychological transformation matched the technical advancement. Crews no longer calculated fuel margins with the grim precision of men expecting to die from empty tanks over endless ocean. Technical Sergeant Kowalski had become an unexpected expert on the new procedures, training ground crews throughout the Pacific on mixture configurations and power operation that maximized fuel efficiency. His maintenance reports consistently showed power plant condition that matched or exceeded standard operational parameters, definitively disproving decades of warnings about oversquare damage. Colonel, Kowalski reported during one of their regular maintenance briefings, power plants operated under Mr. Lindbergh's configurations are actually showing less wear than comparable aircraft run at standard cruise power. Lower combustion temperatures, reduced mechanical stress, and improved fuel atomization are extending service life rather than shortening it. The technical vindication represented more than mechanical validation. It suggested that institutional knowledge codified in training handbooks and perpetuated through military instruction could be fundamentally wrong about basic operational principles. The implications reached far beyond fuel consumption into questions about how military organizations evaluated and adopted new information. Lieutenant Hayes, now one of the squadron's most vocal advocates for the new techniques, had personally flown over 200 hours using Lindbergh's methods. His logbook documented fuel savings that accumulated into tactical advantages measurable in combat effectiveness. "Sir," he told McDonald during an assignment debrief, "yesterday's patrol to Halmahera would have been impossible under old cruise configurations. We flew for 9 hours, engaged enemy aircraft over objective, and landed with fuel remaining for another hour of flight. The human element had proven as adaptable as the technical systems." Aviators initially concerned about 9-hour endurance assignments discovered that reduced power plant noise and vibration from lower RPM configurations actually decreased fatigue during extended flights. Cockpit comfort improved, oxygen system demands remained manageable, and the psychological pressure of fuel calculations diminished to acceptable levels. Major McGuire had emerged as the technique's most effective advocate among combat aviators. His reputation carried weight throughout the fighter community, and his endorsement of Lindbergh's methods influenced aviators across multiple squadrons. "The old way of thinking about fuel operation was killing us," McGuire observed during a gathering of squadron leaders. "Not through mechanical failure, but through self-imposed limitations that prevented us from reaching objectives that should have been within our capability." The strategic implications became apparent as assignment planners realized that P-38 units could now strike objectives previously reserved for longer-range bombers. Japanese installations that had been beyond fighter reach were suddenly accessible to formations capable of flying nearly 10 hours with adequate fuel reserves for combat operations. The tactical balance in the Pacific shifted as American fighters gained operational range that matched the vast distances of oceanic warfare. Word of the fuel efficiency breakthrough spread through unofficial channels that connected P-38 aviators across the entire Pacific theater. Squadron commanders from Australia to the Aleutians began requesting detailed briefings on cruise techniques that promised to extend their operational capabilities. The informal network of communication that existed among fighter aviators carried technical information faster than official military channels. McDonald found himself fielding requests from units as far away as the China-Burma-India theater, where P-38 aviators faced similar range limitations over equally challenging terrain. The techniques that Lindbergh had demonstrated over Pacific waters proved equally effective over Himalayan peaks and Burmese jungles, confirming that fuel efficiency principles transcended specific operational environments. By late 1944, training squadrons in the United States had incorporated the new cruise procedures into standard instruction curricula. Newly graduated aviators arrived in Pacific combat units already familiar with techniques that their predecessors had learned through dangerous trial and error over hostile territory. The institutional learning curve had been compressed from months of combat experience into weeks of systematic training. The statistical evidence became overwhelming as operational reports accumulated. Aviator survival rates improved measurably as fuel-related emergencies decreased. Assignment success rates increased as formations could remain over objective areas for extended periods. Hostile installations previously protected by distance became vulnerable to regular attack by fighters capable of reaching them with adequate fuel reserves. Lindbergh's departure from Hollandia in August 1944 marked the end of his direct involvement with Pacific operations, but his technical contribution continued to influence combat effectiveness throughout the remaining war years. He left behind a cadre of aviators and ground crews who understood fuel operation principles that would serve as foundation knowledge for jet-powered aircraft development in the post-war era. The institutional lesson extended beyond aviation into broader questions about military doctrine and innovation. The P-38 fuel efficiency breakthrough had demonstrated that conventional wisdom even when supported by extensive training programs and technical documentation, could be fundamentally incorrect about basic operational principles. The speed with which new techniques replaced established procedures suggested that military organizations could adapt rapidly when presented with evidence that couldn't be dismissed. McDonald's final assignment report to higher headquarters quantified the transformation in terms that spoke directly to strategic planners. Combat range extended by 31%, fuel consumption reduced by 30%, assignment duration capability increased by 40%. These numbers translated into tactical advantages that influenced air campaign planning throughout the Pacific Theater and established precedents for extended-range fighter operations that would continue through the Korean War and beyond. The quiet revolution that began with one civilian suggestion to try different power plant configurations had fundamentally changed how America's most important fighter aircraft operated in the world's largest theater of war. The lesson was both simple and profound. Sometimes the experts are wrong, and sometimes conserving fuel means winning battles.